Project 3.1, the CharlieClock. This here is the CharlieClock. It has a button and a switch, which unfortunately aren't working now, as well. This is the face, as well as a hinge, so it can stand up as such. As well, there's a hole here, so it can hang from a wall and can be wall mounted. This is the CharlieClock prototype. Of course, it's missing the CharlieClock face, which would start around this green wire and continue all along to this orange wire. That is because there's only one CharlieClock ACES PCB for this project, and it's currently being used. It's soldered into the final build. But this gives a look as to what the prototype looked like, what it would achieve. So unlike with the final product, there is no panel mount button and switch, rather just a 6mm square push button and a simple single pull double throw switch here. The button. Now the button is debounced to avoid multiple presses being read on the Arduino when only one press is done. It's debounced in hardware, but it could be debounced in software as well. There's also a switch here. The base pin is connected to ground through a resistor to avoid shorting, and then the other pins are connected to ground and power respectively. This allows the Arduino to read whether it's high or low, and that is what makes the decision between whether an hour or a minute is added by this push button. Finally, here we have the Pierce gate oscillator. Uses the 32.768 kilohertz crystal, 330 k ohm resistor, 15 meg ohm resistor, and two 12.5 picofarad caps, and this inverter gate here. It should be noted that the whole IC isn't being used. It's only one gate, which you can see only these two pins are being used right here. On the final PCB, only one gate is actually used because the surface mount version, but here, because of the breadboard limitations and the parts that were available for this project, the whole 4069 inverter chip is used, but it's not necessary, which should be noted. Other than that, this is the prototype of the CharlieClock. Now, this is the inside of the project. You can see it's powered by a battery pack. Here you can see the inside of it. Without the batteries is the dimensions. On the back, there is an on and off switch, so you can turn on and off the power to this project. There are slots for 3 AA batteries, which is what's powering it. Each AA battery is about 1.5 volts, so the total voltage of this project is 4.5 volts, which is within the recommended range for an Arduino Nano, or as used in this project, the 18 mega 320p. So you can see this is the custom-made PCB that goes along with the ACES PCB. The main processing unit is a Mega. Most of what's used is similar to the prototype. However, there's also a reset button here and capacitors and a crystal for the Mega to actually work. You can see here there are the CharlieClock pins and holes which line up so that the custom PCB and the ACES PCB can be soldered together and just sit on top of the case. One final note is that this PCB is programmed using this cable programmer. So you can see it slides right in there, and it uses a breakout board. Now this breakout board features the another cable mount and an ISP header. So that's how you program this unit, is with the Arduino Pocket Programmer plugged into a computer. So it should be noted that you can't use the serial monitor for this project, as it has to be programmed with the ISP header. However, this smaller programmer doesn't have as many height limitations as the ISP header right there. All in all, this is the final PCB, and thank you very much. Have a great day.